Okay, hi and welcome to another set of video notes on graphing parabolas. This time though, we're going to graph in standard form. Remember, we are graphing features, or we're trying to find all the features we can from the form so that we can graph it without using a full table. Alright, in this one, we're going to be working with this standard form here. It looks like this. You should be most familiar with this form. It, in general, is the one that may require the most work, but is also the most useful in kind of the way that it plays out. We talked a little bit before about what things we could see. Remember, in the vertex form, it was super easy to see the vertex, so that was revealed to us really nicely. In factored form, it was super easy for us to find the x-intercepts. It was a quick, easy solve, so that was revealed. In standard form, visually, we can initially see the y-intercept in standard form because it's the c value. So c, or the constant, is the y-intercept in this case. So that's the piece that's revealed in standard form. But let's talk about some of the stuff that we're going to do with standard form and how we're going to pull all these features out of it so that we can graph without using our evaluation table. First thing that we should probably do, and again, I guess I should say that there is no particular order for this, right? You can kind of work in any order. This would be the order that I would generally go through, but you can work from any which way you go. So first thing I'd look to do is find the axis of symmetry. Remember that that's going to be x equals whatever the x coordinate is of the vertex. So to get the vertex out of this one, we have to use a little formula that we're going to calculate that for us. We're going to take the coefficients of b and a, and we're going to put opposite b over twice a, and that's going to tell us what the coordinate of the vertex is. So it's not a super hard calculation, but that will give us that x coordinate. Once we do that, we'll have that axis of symmetry, but then we can proceed to find the rest of the vertex by plugging that value in and evaluating to find it, so that we'll get k, in which case we can write that hk vertex. Okay, y-intercept will be given to us essentially, and then after that, of course, we're going to need to find the x-intercepts. In this form, you're going to, in vertex form, you were able to square root to find it. In factored form, you were able to use zero product property. In this one, you use whatever method works best for you. If it's factorable, factor it. If it's not in a square root form, so you won't be able to square root, but you may need to employ the quadratic formula. Because remember, many of these quadratics are not factorable. So it might be just easy enough to go right through the quadratic formula. And then, of course, at that point, hopefully we've got all of our points, but if we do need an additional one to make those nice 5 points, because that's always what we're looking for, then we may need to employ another point by evaluating a different x value. All right, so let's see this stuff in action, but before we do, remember that I would like you here to pause and evaluate that table in. It gives you a little practice on your evaluation skills. I'll meet you here in a second with a filled-in table. Okay, so our table's filled in. You'll notice that I've marked it up. We'll address that as we go, but let's start by first finding that direction of opening. That's pretty easy. We're going to use that a value. In this case, our a value is 2, which means it's positive, so it's going to open upward. So let's go ahead and write that in. Again, it's a nice thing that if you identify that a value, even if you have or are going to do a table, that you know which way it's going to open, because it's nice to have like a general idea of what this is going to look like right off the bat. So that should be the first thing you look for. All right, so now that we have that, we're going to go ahead and attempt to find that axis of symmetry. And remember, the axis of symmetry is going to be calculated by this little value here, opposite b over 2a. Totally worth memorizing. So let's do that quick calculation. So RH is going to be equal to, let's identify our A, B, and C real quick, or at least A and B. Our B value is -4, and our A value is 2. So we're going to have a -4. Don't make that miscalculation by just putting a -4 up there. It will turn positive twice our A value, which is 2. So -4 is going to turn into positive. 2 negatives make a positive. 2 times 2 is 4. So we find out that 1 is where our x-coordinate of our vertex will be, or in this case, our axis of symmetry. So x equals 1. Now, at that point, what we're going to do, and I'm going to have to jump down here so I'm out of space, is we're going to have to plug in, and I got to steal the function here. We're going to plug in that information so that we can find this vertex. All right, so to find the vertex, we're going to evaluate the function at 1, and that's going to give us our y value and our finished vertex. So if we plug that in, we're going to get f of 1, which is going to be 2 times 1 squared minus 4 times 3 minus 6. Except for that won't be a 3 because I was stealing that from the table. It should be a 1. All right, so now we've got 1 squared is 1, times 2 is 2, 1 times negative 4 is negative 4 minus 6, or we have a negative 10 plus 2, or negative 8. So our vertex is going to be the point 1, negative 8. All right, so if we set this back up, we're going to go ahead and confirm. You can see in our table that 1 and negative 8 was what we found in our table, so that does support our work here. So let's go ahead and mark some of this stuff down. So we've got 1 and negative 8. 1, 2, 3, 4, 5, 6, 7. I got to go a little further down. So 8 should be right here. 1 and negative 8. Let's go ahead and mark in our axis of symmetry at this point because we have it. There is our axis of symmetry. And now let's go ahead and attempt to find our y-intercept, which we can see pretty easily is going to be negative 6 from right here. So our y-intercept is going to be 0, negative 6. Let's mark that down. So 1, 2, 3, 4, 5, 6. And we're going to get our point for free from the symmetry that we've already marked down, which will be 1 over to the right from the axis of symmetry. So we've got 3 points. The next set that we have to find then is going to be our zeros, and we're going to have to solve this. So looking at this, I'm going to rewrite the function right here. So I've got f of x equals 2x squared minus 4x minus 6. I'm going to let you in a little secret that there's a GCF in here. So I'm going to go ahead and pull that out. Even though I'm thinking quadratic formula, I'm going to take this GCF out and see if it looks factorable, because factoring usually is a little easier and quicker. So if I take out a 2, right, divide the 2 out of all 3 of those terms, I'm going to get x squared minus 2x minus 3. Let's check to see that quantity inside the parentheses, if it's factorable or not. So we're going to run a little x on it. A times c would go on the top, or 1 times negative 3, which is going to be negative 3, and sum to negative 2. Are there 2 values that multiply to negative 3? The sum to negative 2. And I believe there is. I can use a negative 3 and a positive 1, and that's going to go ahead and multiply to negative 3 and add to negative 2. What does that mean? It means I'm going to factor this because a value does equal 1. So I get to do this. 2 times the quantity of x minus 3 and x plus 1, which means that this is going to not be true because 2 does not equal 0, so that one's not a possible solution. But I can take the next 2, x minus 3, and set it equals 0, and I can take x plus 1 and set it equals 0, and find out that my x-coordinates are going to be 3 and negative 1. So let's write those as points. So we're going to have the point 3 and 0 and negative 1 and 0. So let's mark those down. 1, 2, 3, and negative 1 and 0. Double check our symmetry. It's 1, 2 away. Looks like I didn't count that one quite right. 1, 2, 3. Should be right there. 1, 2 away, 1, 2 away. And greatly, or nicely, we have enough points to graph our parabola. Again, not V-shaped, so make sure that it's got a nice rounded bottom to it. And we're going to extend up here, do our best to do one line. And there's the right side. And the graph over here on the left. And extend up nicely. See how easy it is to graph when you got those points there? All right, so now we can identify all the rest of the information that we need to identify. Increasing interval is opening and increasing from left to right, or the y values are increasing on the right side here. And the y values are decreasing from left to right from negative infinity, it looks like, down to the vertex. So there's our decreasing interval. All right, so let's write those in. Let's grab Brad. So the increasing portion, starting at our vertex. Remember, we're dealing with x value, so the x value of 1. So it's increasing from 1, not including, because that's the point of turning. It's the x values from 1 all the way to positive infinity, because that's going to increase forever. And the decreasing interval is going to decrease from all the way over here in negative infinity. It's coming down, coming down, coming down until we hit the vertex. So we're going to have negative infinity, not included, all the x values all the way up to positive 1. Again, we're looking at the x-coordinate, not the y-coordinate for this. Which takes us to end behavior. And end behavior, again, is going up on the right and up on the left. So let's mark that down. So we're going to write, I'm going to grab a smaller pen for this, as x goes to negative infinity, which represents the left side, f of x is going to positive infinity, or up. As x goes to positive infinity, or the right side, f of x is going also up. So we're going to write positive infinity. Our domain should be the same as all the rest of them, meaning that we're going to find this from all the way to the left to all the way to the right. So that means all real numbers. So domain then is all real numbers, a nice bold R. And our range, because this is a minimum vertex, will be whatever that y-coordinate is at negative 8, and it's going to increase up to positive infinity. So our range will be from negative 8 included, because that is the lowest point, all the way up to positive infinity. All right, now let's change this to vertex form. Why? Because again, we don't know what they're going to ask, so we might as well practice the skill here. So to change the vertex form, guess what we need? We need that there, which is the vertex. We need to know what the generic form of the vertex form is, which is here. And we got that. And the only other piece we need is what the a value is in the form that we're at. It happens to be a 2. We're going to steal the a value. We don't even have to calculate it because we can see it. So here's what we're going to write. We're going to take our vertex, which was 1 and negative 8. We're going to write it into this form, f of x equals a times x minus h squared plus k, and we know our a value is 2 because we stole it. We got everything we need. So let's write this out. F of x equals 2 times x minus my h value, which is 1, so it's going to look like a negative in there, squared minus 8. Not bad. Factored form. Great thing we factored over here, because guess what we did when we factored? We got to factored form. So there's our factored form. So we're going to write f of x equals 2 times x minus 3 and x plus 1. Little note here on the factored form. If it's not factorable, guess what? You can't write into that form. So if it isn't factorable, no factored form for you. All right. So now that we've said all that and done it, we were able to graph another function, in this time in standard form, by finding all of the same major features that we've been looking for and graphed without our table. Again, looking back at our table, we can see our symmetry. There's our vertex, 1, negative 8, and you can see it goes negative 6 and 0. And on this side, again, it also goes negative 6 and 0. So you can see our symmetry, our y-intercept was in there, and it just so happened that we did graph our x-intercepts, and that supports what we did. All right, so you should be able to graph by standard form. We'll see you in class now for a few examples. Thanks for watching.